interrupt input. Okay, so I won't explain this. If you have time, you can implement this one. But it's not in the fundamental feature. And I don't have time on that. So I want to talk about another very important thing for the interrupt. Is the interrupt priority. Okay? So whenever you have more than one interrupt inputs in your system, you need to consider about the priority issue. Okay? Whenever you have greater than one interrupt input, you need to consider this. Okay? So if you think about your assignment 2, how many interrupt you at least have? You haven't go through the whole question, but you realize that you have specification like your 7 segment needs to count every 1 second. Your RGB needs to blink with certain frequency. Those kind of things, if you want to do that, what do you need? You need systics. Okay, so you definitely have cystic inside. Okay, you have cystic interrupt. Okay, so at least you have cystic interrupt. And what else do you have? You have another feature is one button needs to be pressed twice within 1 second. Right? So how do you implement that? If I ask you to press a button twice within 1 second, okay, I ask you to check whether that person press the button 2 times within 1 second or not. How do you check? You use a stopwatch, right? When the first time he pressed, you need to start your stopwatch, right? Start it when it's firstly pressed and the clock runs, right? And then when the second time he pressed, you stop your watch, you look at the time, right? If it's less than 1 second, means he did this correctly, right? If the time is longer than 1 second, means it's not satisfied the requirement, right? So you see, to achieve this feature, you need to implement your push button as interrupt. Why? Because something needs to be triggered based on the push button immediately. What event is triggered by the push button? I described the story for you already. When the button is pressed, what should you do immediately? What is this in my left hand side? What is this? What am I holding? Come on, guys. A watch, right? So every time when you press, you need to record the time. The time recording event must be happen quickly by the push button. You don't want someone press and then you wait for quite long, then you start the time. That's not the correct way, right? How to time the press accurately is when people press, you want to press your watch immediately. Okay? So this is your follow-up event. You want to record the time immediately if the button press is detected. Okay, and then second time as well, if the button is pressed for the second time, you want to stop your watch or you want to record the time again. Okay, so the time recording this event must be done quickly. That's why you want to implement your push button as an interrupt, because you want it to trigger something quickly. Okay, so you at least have one push button also working as an interrupt. Okay, so at least you have 2 interrupt signals to hit the basic requirement. Okay, So that's the reason in your assignment 2 you must consider the priority issue. Okay? Because there are chances that these two happens at the same time. Okay? Means someone just so lucky that when he press a button is in the milliseconds that you want to record the time. The millisecond that you want to increase your MS ticks. Okay? Although the chance, the opportunity these two hit is very, very rare, but there is a chance. Okay? So for people who are designing the hardware, you better consider all the possibilities. Right? You build a boat, you need to consider all the accident it might happen. Okay? Although maybe the chance for certain accident happen is quite rare, but you still need to consider about that. Okay? So same thing here. You need to consider the case when these two happens at the same time. So you need to tell your NVIC that which one is more important and what should be happen if these two occurs at the same time. Okay? So all these are done by priority setting. Okay? So these are the system exceptions. Remember some internal important thing that your Cortex-M3 may have. Okay, you can have reset, hard fault, bus fault, all this. Okay, SysTick, and anything you implement, for example, your push button. The push button will be an external interrupt. Right? It's connected to your EINT3. EINT3, E stands for external. Okay? So you basically have a bunch of registers, again, for interrupt priority management. Okay? So these registers are basically for your external interrupts. Okay, for external interrupts. So this register, okay, you have a bunch of registers, they look like this. They look like this. So you have register, interrupt priority register 0, register 1, register 2, and so on, register 8. Okay? And each of them is a 32-bit register. So each of these 32-bit. Okay? And basically you are using these bits to set the priority of certain device. So for each device, you are actually using 8-bit to set the priority. Okay, so this one is each device. Sorry. So each device, you have 8-bit to talk about its priority. Okay, so basically each register you can set up to 4 devices. Okay, so that's how it works. And let's zoom into this 8-bit. Okay, so these are the 8-bit. In general, it's like that. But for our particular hardware, LPC1769, okay, the hardware manufacturer already fixed these 3 bits as 0. Okay, so if you look at these registers, these 3 are 0, these 3 are 0, these 3 are 0, these 3 are 0, 0. Here, they are zeros. Okay, so within this 8-bit, you can only use 5 of them. Okay, you have 5 of them to use. Okay, and you are basically need to use 5 of them to define the preamp priority and the sub priority. Okay, you are using these 5 bits to define 2 things. Okay, preamp and sub. So I will explain what the meaning of preamp and sub in the next slide. But here, what you need to know is IPR width for LPC1769 is 5 bits because there are 3 that you cannot use. Okay, and then for the rest of the 5, basically you have the freedom to decide how many of them you want to use for preamp, how many of them you want to use for sub. You have the freedom to choose. Okay? Basically, at this moment, you just need to know that using 5 bits to set 2 things, you can decide how many to set the first one, how many to set the second one. Okay? And the way you choose is actually what we call priority group. Okay? So this one means like preamp and sub. Okay? So how many use for this, how many use for this? I'll explain this one in the next slides. Okay? So here, firstly, I will explain what's the difference between this. What's the meaning of these two? Okay, preamp and sub priority. So let's look at an example. Okay, so let's say you have a main program. Okay, let's say you have a main program, and let's say this is your computer. Okay, computer running, this is your main program. Okay, and then I define my keyboard as an interrupt. Okay, I define my keyboard is an interrupt input. Which means while you are running your main program, when someone triggers the keyboard, you want to do something extra. Right? You want to do something special for this trigger. Okay? So basically what will happen is, okay, so basically horizontally this is in time. This is in time, okay? So while you are running your main program, someone triggers the keyboard, you will pause your main program. You are running basically the follow-up event due to keyboard. You run it, only when you finish it, you will go back to your main program, start your main program. Okay? Because keyboard is an interrupt. Okay? And let's say I set it like this, preamp priority 1, sub priority is 1. Okay? Just remember the number, okay? So later you will realize the meaning of them. Then now, let's say I have 2 interrupts now. I have keyboard and a timer. Timer is also an interrupt. Okay? And I set my timer's interrupt. Can you compare these two? So can you see that the preamp priority, this guy is 0, this guy is 1. Okay, just look at this, the preamp priority. This one is 1, this one is 0, this one is 1. Okay? So what will happen is like this. While your main program is running, let's say someone press a keyboard, you start to run something about keyboard. Okay? But during this moment, okay, you're supposed to finish here, okay, if no one disturbs you. But in middle, somehow, my timer gets triggered. Because timer has a small number of preamp priority. The smaller the number, the higher priority it is, the more important, basically, it means, okay? So your timer is more important than your keyboard. That's why your timer basically kick out your keyboard, whatever is running is stopped. And you start to run something about timer. Only when this guy finish, you go back to where you're from. Your keyboard haven't finished, right? So you start to run your keyboard until it finish, you go back to your main. Okay? So this shows what happens if an interrupt with higher preamp priority come in. You will see something like this. Okay? And now, let's introduce one more. Let's say you have 3 interrupts. Okay? So I have a mouse. Okay? So if you look at these 3, can you see that timer basically has the higher preamp priority than the other 2? Okay? And the other 2, your mouse and keyboard has the same preamp priority, but this guy has smaller sub-priority value. Okay? So which one is the most important one? No, among these 3, which one is the most important one? Your timer. Okay? Then what's the second? Your mouse. Okay? So after you compare your preamp, you compare your sub priority. Okay? Then mouse is the second position. Then keyboard is the last one. But these three are all interrupts. Okay? Then for case 3, if I'm running the main program and my keyboard gets triggered, I start to run the keyboard. Okay? And while I'm running the keyboard, someone triggered the timer. Since the timer has higher preamp priority, it kick out your keyboard, start to run timer, and once it's finished, you go back to where you stopped just now, start to run keyboard. But while you are running keyboard, can you see that someone maybe touched my mouse? Okay? So there's a trigger for my mouse. But since these two have the same preamp priority, so this guy, although is important than keyboard, it cannot kick off keyboard. Can you see that? It will wait. It will wait until your keyboard action finish, it run mouse. Then you go back to the main. Okay? The last one, show a clearer picture. So if you are main program, your timer gets triggered, you start to run timer. But while you are running timer, can you see that keyboard coming in, mouse coming in, and keyboard is in front of mouse. Can you see that?
Yes.
But since this tool has lower preamp priority than timer, so neither of these can kick out your timer. So timer will run. But after timer finish, can you see that your mouse will run first? Although the trigger is later than your keyboard. Okay, although the trigger is later than this, you still run the mouse first because mouse is more important than your keyboard. If you look at the sub priority level. Okay, so mouse will run. Once mouse finish, you will deal with this guy, this trigger. So you will run keyboard, then you go back to main. Okay, so look at this example, you understand what's the meaning of preamp, what's the meaning of sub priority. So basically, you can see that if let's say two devices have different preamp priority, basically it means this tool has very significant priority level difference. Okay, if this one happens while this one is running, I don't want to terminate this one. This one is very important. No one should terminate it. Okay, but for the devices with same preamp priority but different sub priority, they are just a little bit different on the priority level. Okay, so they are more or less the same, but you still need to differentiate them. Which one goes first? Which one goes next? So you give different sub-priority level. Okay? So later on, remember you need to use these 5 bits to do this. Okay? So see, if I want you to use these 5 bits to do this, basically you need, how many preamp priority level do you have here? You have 2 only, right? 0 or 1, that's all, right? So if you only have 2 possibilities, how many bits do you need? You only need 1 bit, okay? So within this 5 bit, you can just use one of the bits to issue the preamp priority level, okay? And then use out all the others for the sub priority. Okay? So you see how to choose how many to use for pre, how many use for sub, or how to draw this line, where to draw this line, depending on how many levels you want to set for your preamp. Okay? Let's say if you want to set 3 different levels, then you need 2 bits. 1 bit is not enough. Okay? If you are setting 4 different preamp priority levels, you still need minimum 2 bits. Okay? So that's how you decide where to draw this line, basically. Okay? So that's the idea. Then how to define like how many levels you want is actually depending on how you want your system behave. For example, this one. Okay. Just now I show you why it behaves like this because we set in that way. But in the real practice, people always define how this behaves first. They will think, okay, there's a moment when 3 of them happens at the same time, like this. Okay, the engineer, okay, programmer start to think how I want my system to behave. I don't want this 2 to kick out this one. So I know that timer should be higher preamp priority level than the other 2. And then you think about it, when these 2 happen at the same time, do you want one kick out with the other one? If no, you can set the same preamp priority level. Means you don't want one kick out the other one. Okay, for example like this, right? This happens when this one is running. You don't want your mouse kick out your keyboard. Then you set them the same preamp priority level. And then you think about it, okay, which one is more important? Usually people use mouse more frequently, right? So I set this one a little bit higher priority than the other one. So you set this one 0, set this one here, you differentiate it from here, not here. Okay? So these are the numbers because of this. Okay? So for your case, you have SysTick, you have SW3. So you need to think about it. 2, okay, 2 is still simple. You only have 2, okay? 2, you need to think what do you want your system behave if these 2 happen at the same time? Means if, okay, so your 2 event here is, okay, you have SysTick, you have SW3, okay? So basically the square I draw here, okay, for example this one, okay? This one, this is not a button press. This is a button press. This is a moment of button press. This is something should be done when button is pressed. Okay, this should be the reaction. This should be the reaction of your interrupt. This is not the interrupt. This is the moment of the interrupt. Okay, so for your SysTick, if I draw, let's say SysTick interrupt occurs. What is actually the follow event you are doing here? This is actually the thing inside your handler, right? Whatever inside your handler is a reaction. So what did you write inside the SysTick handler? What did you write? Remember? Previously, what did you write inside the SysTick underscore handler? What did you write inside this? Come on, look at your code. Temperature sensor. What did you do inside the SysTick handler? MSTix++. Right? MSTix++ is a timer increase. Okay? Is your watch like keep moving, okay? So whatever here is MSTix++. So what you have here is you are like run your watch basically. You have a watch. This is like a watch, right? So run your system clock. You generate a clock for your own system. Okay? So this is a follow-up event. Then for your SW3, again analyzed in the same way. Okay? So this is the moment when SW3 is pressed. The follow-up event here is whatever inside handler. Inside EINT3 handler. Okay, the follow-up event you want to trigger by SW3. Then you need to think about it. You have two of them. There's two possibilities. One is while this one is running, your SW3 gets pressed. Or the other way, while you are doing something here, your cystic interrupt happen. How do you want to behave? How do you want your system to behave? Okay, let's look at this. Something you want to do, okay, not sure yet, you haven't write your code yet, but you are doing something, right? So, if cystic interrupt happens, do you want to run your clock immediately? You better have that, right? Because this is your watch. You want your clock to be accurate. Okay, you don't want to buy a watch which is random time, right? So, this one better be able to keep the other out. Okay, which means these two, they should have different, what priority? Preamp priority. Okay? Then it's easy because you only have two. So you basically have two preamp priority level. And in each preamp priority level, you only have one device, so you don't need to discuss about the sub-priority. Okay? But if you have more than two, you need to think about that. Okay? So once you have done this, basically what will happen here, what will happen here is this one won't be able to keep this thing on. It will run after that. Okay? So this is something you need to decide first. Then the thing is how to code it, how to write the code. Okay? Let's say you are using, let's say I draw a line here. Okay, for this case, okay? Maybe I don't talk about this, but for this case, let's say I want to use 2 bit. Okay, let's say I want to use 2 bit for my preamp. All the others for my sub-priority. This is something I want to set. Okay? And then what you need to do is look at this table and figure out what is your priority group. Priority group 0 means you are using bit 7 down to 1 for your preamp priority. Okay? Take an example. Let's say this one. This one actually means, okay, so it means if you set to preamp group 0, you are using 7 down to 1 for your preamp. You want to leave the last one for your sub. Okay, so basically this is this one is this. But you know from hardware point of view, this 3 will be always 0 that you cannot change. Okay? So what will happen? What will happen is you will have all these 5 bits for your preamp priority. Okay? So every individual device, they have different preamp priority. Okay? All the devices, they have different preamp priority. You don't differentiate them by sub-priority, you are differentiate them by preamp priority. Okay? But let's say you are doing, okay, so if you want to draw the line here, means you want to use this 2 for preamp, the others for sub, you should choose group 5. Can you see that? Bit 7, 6 are used for preamp. Okay? So here you will get bit 7, bit 6. These 2 are preamp. All the others are sub. All the others are sub. Although the last 3 you cannot change. Okay? So if you want to draw the line over there, you need to choose group 5. Okay? So let's say if I want to draw a line here, which group I should choose?
6.
Group 6. If you want to draw a line here, means all the bits are used for sub-priority. All the devices are in the same preamp priority. What group you need to choose? 7. Okay? So that's how you decide your group number. Okay? So to set this one, you add this line. Okay? So there's a function called NVIC set priority grouping. Put 5 over there. Okay? So again, this is a setting. So you must write this one before your 1-1. Okay? And once you have done that, basically you draw a line here. You have 2 bits for preamp, 6 bits for sub-priority. And 3 of them cannot use. Okay? Then let's have an example. Let's say I have 1, 2, 3, 4, 5, 6 interrupts. Okay? And I have already drawn a line here. Okay? And now you see, by using 2 bits for preamp, you can set maximum 4 preamp priority level. Right? So if you look at this, this is how I set. Can you tell me which one is the most important one? Cystic. What's next? ENT 0. You look at 0, 1. These two are 0, 1. Then compare this one. Okay, this one small number, smaller number. So this one more important. So this is the second one. This is the third one. What's next? ENT 3. Then timer 0. Then timer 1. Okay. So then you use 2 bit. So the sub priority will be this 3 bit. So if I write the whole 8 bit, it will be like this. The last 3 always don't change. Okay? Then let's say this is the one. This is the table that you want to set. You want to set them in this way. You need to write here. Okay? So how you write here is you use NVIC set priority function. Okay, and for example, the first one you are setting is cystic. Okay, this one. Okay, so let's look at this function. Okay, let's see how to write. So let me see whether I have an example. Okay, I don't have that one. But let's say I wrote it here. Okay, something before 1, 1. Okay, somewhere here. Okay, maybe I put it here. Okay, so you should have NVIC set priority grouping 5. Okay. To see whether typing is correct, if typing is correct, it should be recognized. So you should be able to see something by right-click Open Declaration. Okay, so if you open declaration, here's a description of the function. So the priority group, the input you write here is a grouping field. Okay, so it's explained in this way. Okay, it's basically that table I showed. Okay, and then you add. Okay, let's say you already know you have those many interrupt. Then you need to tell each what's the level. Okay, so for example, just now, okay, I wrote it here. Okay, so because you cannot see my table now. So just now we said the cystic interrupt. So its preamp is 0, 0. Okay, and its sub priority also 0, 0, 0. And then the complete 8-bit is 00, 000, 000. Okay, and then you have the next one. Okay, you don't need to write in the sequence. Okay, so just choose another one. Let's say EINT3. Okay, EINT. Let's say 0. No, let's say timer. Okay, timer 0. So timer 0, I have preamp is 10. Okay, and I have sub priority is 001. Okay, so it will be 10, 001, 000. Okay, so let's say I want to write these two. So the function you need to call is nvic. Okay, set priority bracket. This is the function. Okay, and inside this you have two things to pass. One is the interrupt, the name of the interrupt here, and one is the value. Now how to use the function again? Okay, so I think I typed wrongly. Nvic set priority. This doesn't get recognized. You see something is wrong. Okay, but it should be the same for this. Let me look at this. Set priority. Okay, so this is the name. Copy. I think I somehow typed wrongly. Well, anyway, look at the function. Here's the function. So you need this input. You need this one. Okay, IRQ type. Okay, so IRQ type. You see the name is not a C data type, right? So we must define it by ourselves by the library. Okay. So you want to know how to write this. For example, I want to do timer 0. I don't know how to write, right? So you go here, right click, open declaration. Can you see that? This is the data type we define, and all the names are here. So all these can be the interrupt. Okay? From here, you see all the way down. So the library who created the library defined this one, and this guy can only handle this name. So if you type wrongly, it doesn't belong to this one, it doesn't get recognized. So you see here you have SysTick IRQN. So this is basically for your system tick interrupt. So you need to copy this one over if you want to set the SysTick. Okay? So copy it here. Okay? That's the first one. Then the second one, you have the priority level, which is a 32-bit unsigned integer. How to write this? Okay, you see here is a priority to set. Okay, so here, okay, so if you look at the code here, so here actually over here, you are not writing the entire 8-bit. Remember here, for every interrupt, you have totally 8-bit. Okay? But here, actually, you don't need to write 8-bit because if you look at the code, okay, where's the code? Okay? It's doing the shift for you. Okay? So basically, you just need to write the first 5. So for example, for this one, it's easy, right? It's just 0. Okay? The SysTick is easy, 0. Either you see this one or you see the entire one, they are 0, so just 0. So the second one, let's say how to set the timer 0. So for timer 0, look at the name from here, okay? So can you see timer 0, this one? Copy the name, make sure you have the same name here, okay? Then the next value here, you just need to basically consider the first 5-bit. Okay? So this one part you can actually ignore. When you are inputting the second parameter, you don't need to consider the last 5. So what is the number for 10001? What is this number? In hexadecimal. Okay, so this is the way I write. What should I put here? This one is 1. This one is also 1, right? In front is 0, so it's 1. Okay, so here basically you are only considering the first 5. If I'm not wrong, let me double check. I think so. So basically, you know what we are doing, right? We try to set the correct. So now if I set if I write another one, just now the one in my table, okay? I have the EINT 0. I have the EINT 0, which is 01. Okay, the sub priority is 0, 0, 0. If this is the one I want, so here will be 0, 1, 0, 0, 0. So here, okay, what I need to write here is the name of your EINT 0. Okay, so go this location, find EINT 0. Can you see that? This is the name. Copy, paste it here. Okay, and then here, what's the number of this one? If you just consider 5 bit. 08. Okay, so this is the way you write. Okay, and then to include this one, I think you need to, you see the value here come from here, so you need to include this header. Okay, and then you also need to include this header. Oh, sorry, not this one. So I need to include this header because the name from that. Okay. Okay. So let me delete this one. So I build. I should have no error. Okay, just build. Something's wrong. Let me see. So expected bracket. Where it goes wrong? Build. Cannot get space over there. Okay. So here, just consider 5 bit because inside this function is actually doing the shift for you. Can you see that shift? 8 minus something is actually shift the thing with 3 zeros followed. Okay, so it's actually inside the function is add the 3 zeros for you. Okay, so here you just need to consider the 5 bits. Okay, so this thing must be done if you have more than 2 interrupts. If you don't do this, sometimes you may not realize it because it's very rare when 2 interrupts happen at the same time. But suddenly, suddenly your board doesn't work or behave very weird. That's because some of this kind of setting didn't do properly. Okay, so you better have that one to make sure that you include all the possibilities. Okay. So this is basically the very last thing I want to mention, except the transmission part. Okay. So by now you know everything already. You know your okay. Oh, sorry, one more thing here. I need to explain. Last thing. So just now I show you how to set the SysTick handler, SysTick interrupt using this value, right? But actually, remember when we enable this, we have the SysTick config function, right? If you look into it, okay, if you look into the function open declaration, there is actually a setting for the priority. Inside the function, it already has some guys set the priority for you. So go into this and check what is the priority level set by person who wrote this function. That may not be the one you want, you know. So if that is not the one you want, you need to add in the line that I just typed. If you want 0000, okay? And make sure that the line you added is after this one. Okay, if it's in front of this one will be, you know, update the priority level. Okay? I mean, certainly you can go in and delete the thing you don't want, but I just don't recommend you to modify the library. Okay? So add one more line after this to set the SysTick priority level to a new value you want. Okay? And then if you don't set this properly and you set your SW3, you know, something may go wrong. You need to know this one first. Then you can set this one, the switch. Okay? So read about this function. Okay, that's all. So we'll have clinic this Saturday as well. It's an afternoon class because